So we worked with operations on radicals. We've simplified radicals. The last thing that we do with radicals is we solve equations, okay? And the best way to show you how to do this is, again, just by doing lots of examples to show you all of the different kinds of equations. So a couple of things to remember. Our goal is to solve for x. That's what solving an equation is, okay? So, or whatever variable it is. Okay, so first example. We have the square root of x minus 3 is equal to 4. So if we want to solve for x here, the first thing that we want to do is we want to get rid of the radical. So something that isn't an issue here but will be an issue eventually is that the radical needs to be isolated. And it's not an issue here because the radical is already isolated. So I'm going to write that down as our first step. It's just not an issue here because it's already isolated. So just like with absolute value, we said isolate the absolute value first. Same thing here, isolate the radical first. Then we need to get rid of the radical. So in order to get rid of the radical, we're going to square both sides. So if we do that here, we're going to take the square root of x minus 3 and square it. And we're going to take 4 and we're going to square it. And when we take the square root of x minus 3 and we square it, we're undoing the square root, right? They undo each other. This is 1/2 raised x minus 3 to the 1/2 raised the second power. If we multiply, we just get itself. So just lots of different ways of saying the same thing. By squaring the square root disappears. So on this side, we get x minus 3. And on this side, we get 16. Okay, so the next step is to solve the equation for x. And this equation may vary depending upon the type of equation that you have. You may wind up with something linear, which is what we have here, or you might wind up with something quadratic, which we'll see. Sometimes the equation can be even more complex. We're pretty much sticking to linear and quadratic here, okay? So if we solve this for x, we add 3 to both sides. And we get that x is equal to 19. Okay, now we have one more step here that we can't forget. And the last step is to check for extraneous solutions. So you've seen this a little bit. You saw it when we were dealing with logs. That a log, the argument in a log cannot be less than or equal to 0. Okay, because the domain of a log is only x values that are greater than 0. Here, sometimes you're going to get an extraneous solution as well, because the solution x equals 19 is a solution to this equation x minus 3 equals 16. It doesn't take into account that the original equation had a radical in it. And because it doesn't take that into account, sometimes because you're squaring, you're getting a solution that does not work. Okay, so because you're creating a new equation in the process of solving, sometimes you could get an extraneous solution that works for that new equation, but not for the original. Okay, so because of that, you always need to check. So you want to check to make sure your solution is not extraneous. Which means it's a solution to the final equation, but not the original. Okay, so this is a little bit different for every type of function that we deal with. For logs, we plugged it into the argument to make sure that we got a number greater than 0. Okay. For this, we plug it into the original equation to make sure that the original equation holds true. Meaning the left side is equal to the right side. This is a D. Okay, so in this case, you would be making sure that the square root of 19 minus 3 is in fact 4. So the square root of 19 minus 3 is the square root of 16. Is the square root of 16 4? Yes. So x equals 19 is an answer here. Okay, it's not extraneous. Okay, and these are the 4 steps that you're going to follow for every single equation that you have. Okay, let's take another example. So let's say that we have the square root of x minus 4 plus 8 equals 3. Okay, so we're going to isolate the square root. Subtract 8 from both sides. Square root of x minus 4 is equal to negative 5. Okay, so we isolated. Next thing that we're going to do is we're going to square both sides. So that's going to give us x minus 4 is equal to 25. Okay, so we squared both sides to get rid of the radical. Now we solve the equation for x. Add 4 to both sides. When we add 4 to both sides, we get that x is equal to 29. You have to plug back in. So square root of 29 minus 4 plus 8 is equal to 3. Well, here we have square root of 25 plus 8 is equal to 3. Square root of 25 is 5. 5 plus 8 is not equal to 3. This solution is extraneous. It's not a solution. Okay, which if you think about it from the very beginning, it really does make sense, because when you isolate the radical, you get that the square root of x minus 4 is equal to negative 5. And we already know that you can't have the square root of a real number being negative. Let me rephrase that. When you take the square root of a real number and it's negative, when you square it, you wind up with something positive, right? So when you take the square root, if we were to plug it into 29 here, there's no way that we're going to get a negative 5. Okay, let's take another example. Okay, just have a bunch of these for you. We're just going to go through a whole bunch. So let's say, and again, this is a case where what you want to do is, there's nothing really new that you're learning here. Everything is just, following those same 4 rules. So stop the video, try it on your own, okay? So the third one, square root of 3x plus 5 minus 2 is equal to negative 1. So again, we isolate. So we're going to add 2 to both sides. We're isolating the radical. That's going to give us square root of 3x plus 5 is equal to 1. Then you're going to square both sides. That's going to give you 3x plus 5 equals 1. Here we can subtract 5 from both sides, because now we're solving for x. That gives us 3x is equal to negative 4. And from there, we would divide both sides by 3. Giving us x is equal to negative 4/3. Okay, so we need to make sure that it's not extraneous. So we have square root of 3 times negative 4/3 plus 5 minus 2 is equal to negative 1. So this 3 will cancel, and we get the square root of negative 4 plus 5. Is equal, minus 2 equals 1. Equals negative 1. So negative 4 plus 5 is 1. So square root of 1 minus 2 equals negative 1. Or 1 minus 2 equals negative 1. This is true. So this is not extraneous. This is an answer. Okay. Okay, let's take another one. Square root of x minus 2 plus 3 is equal to 5. Okay, so here you want to isolate. So we're going to subtract 3 from both sides. That's going to give us square root of x minus 2 is equal to 2. Square both sides. Okay, so remember, we isolate the radical there. We get rid of the radical here. And our next step is going to be to solve for x. Because this gives us x minus 2 is equal to 4. Add 2 to both sides. And we get that x equals 6. We're going to check if it's extraneous. Square root of 6 minus 2 plus 3 is equal to 5. So square root of 4 plus 3 equals 5. 2 plus 3 is equal to 5. X equals 6 is a solution. Okay, notice we followed all the same steps. Isolate the radical, subtract 3 from both sides, get rid of the radical by squaring both sides, solve for x. In this case, it's just a simple linear equation, and then plug it back in to make sure it's not extraneous. So we plugged it back into this original equation here. Okay, now the next one is just slightly different. Let's say that we had the square root of 4x minus 7 is equal to the square root of 3x plus 9. Okay, so in this case, we have a radical on both sides. When we have a radical on both sides, we can't really isolate the radical. What you're doing is you're making sure that you have a radical on each side so that when you square both sides, you get rid of the radical. Okay, so in this case, it is kind of isolated because we have one on each side. Okay, so that's what you want. Okay, so what we're going to do here is it's already isolated, so we square both sides. And when we square both sides, we get 4x minus 7 is equal to 3x plus 9. So we got rid of the radical, and now we're going to solve for x. We could subtract 3x and add 7 to both sides. And that is going to leave us with x. The 7's cancel, the 3x's cancel. So we get x is equal to 16. Now we plug it in to the original. Square root of 4 times 16 minus 7 is equal to the square root of 3 times 16 plus 9. Well, 4 times 16 is 64. Three times 16 is 48. We get square root of 57 is equal to the square root of 57, and that's true. So this, x equals 16, is a solution. Okay, and just to be clear, if this were an exam, you need to show that you checked for an extraneous solution. You can't just, box it and I'm supposed to read your mind. Okay, you have to show that you somehow checked for an extraneous solution so that I know that you knew to do it. If you just box your answer, even if it is not extraneous, I'm not going to know that you knew to check for that. Okay. Let's try another one. So 3 times the square root of x plus 2 plus the square root of x minus 4 is equal to 0. Okay, try this on your own. It's actually not any different, okay? It looks more complicated. We want one radical on each side, okay? Just like we said here in this last one. One radical on each side, right? Same thing applies here. One radical on each side. So what we're going to do is we're going to subtract the square root of x minus 4 from both sides. This is what we mean when we say isolate. And the only thing here that makes it a little bit different is that you cannot get rid of this 3, right? Because if you try and get rid of this 3 in front of the square root of x plus 2, the only way to do it would be to divide both sides by 3, but then you're going to have it on the other side. So you can't do anything about it. So you just square both sides at this point. That still will help you get rid of the radical, because what's going to happen is the square root is going to go away, but remember that this 2 gets distributed, right? So it's going to get distributed to the 3, and it's going to get distributed to the square root of x plus 2. So what you wind up with is 9 times x plus 2. Okay, that 2 gets distributed. And then negative square root of x minus 4, this 2 is kind of also getting distributed. If you square a negative, it just becomes positive. And this is going to give you 9x plus 18 is equal to x minus 4. So we got rid of the radical, and now we're going to solve for x. So we can subtract x and subtract 18 on both sides. Okay, the 18s will cancel, the x's will cancel, and what we are left with is 8x equals negative 22. Divide both sides by 8. And we get that x is equal to negative 11 over 4. Okay. And yes, this is annoying because it's a fraction and we have to plug it in, okay? And that's annoying because now when we plug it in, we have to double check that it all works. You can, because 11 over 4 is a perfect decimal, okay? In other words, you get 2.75. You could plug in negative 2.75. I don't care, okay? That's fine. Make sure to reduce your fraction if possible. Okay, so we need to plug it in. Three times the square root of negative 11 over 4 plus 2 plus the square root of 11 over 4 minus 4. So what we do is we multiply everything by 4 over 4, right? This is going to be multiplied by 4 over 4. So we get 3 times the square root of negative 11 over 4 plus 8 over 4 plus square root of 11 over 4 minus 16 over 4. What you're doing and you're saying, is this equal to 0? Okay. Again, if you want to plug in 2.75, that's fine. Negative 2.75. Here we get 3 times the square root of negative 3 over 4, which automatically is going to be a problem because you can't take the square root of a negative number here. And negative 27 over 4. That does not work, okay, because you can't take the square root of a negative number. This is extraneous. Okay, when you simplify these and you add them, you pull out the I, and you're going to get an imaginary number as your answer. Okay. And 27 over 4, even if you reduced it and you pulled out the I, you still wouldn't get 0. Okay, next one. We have square root of x plus 5 minus x equals negative 1. You're going to add x to both sides. That's going to give you square root of x plus 5 is equal to negative 1 plus x. We square both sides. So we isolated the radical, now we're squaring. Now when we square this, on the left we get x plus 5. On the right, this is the same thing as x minus 1. So actually I'm going to rewrite this as x minus 1 because I think it's going to be clearer. So x minus 1 squared is x squared minus 2x plus 1. Okay? This is x minus 1 times x minus 1. Do not distribute the square. So now we can subtract x from both sides and subtract 5 from both sides. I personally prefer things on the right. I personally prefer my 0 on the right when I'm dealing with quadratic. This is going to give us x squared minus 3x minus 4 is equal to 0. This is a quadratic. You have to solve the quadratic. Okay? So when we solve the quadratic, two numbers that multiply to negative 4 but add to negative 3 are negative 4 and 1. So this becomes x minus 4 times x plus 1 is equal to 0. X minus 4 equals 0. That should be a minus. And x plus 1 equals 0. So we have x equals 4. We have x equals negative 1. What we want to do is plug it in to see if it's extraneous. Square root of 4 plus 5 minus 4 equal negative 1. Well, this is square root of 9 minus 4 is equal to negative 1. 3 minus 4 equals negative 1. This works. Here we have square root of negative 1 plus 5 minus negative 1 equals negative 1. This is square root of 4 minus negative 1 is the same thing as plus 1. 2 plus 1 is not equal to negative 1. So this is an answer. X equals 4 is an answer. X equals negative 1 is extraneous. Okay, let's quickly do 2 more, and then we'll stop. 2 more just like this, okay? So square root of 2x plus 7 minus x is equal to 4. Add x to both sides. That's going to give us square root of 2x plus 7 is equal to x plus 4. Notice I put the x first just because it's what we're familiar with when we square, and addition is commutative. Square both sides. So we isolated the radical. We're getting rid of the radical. When we square both sides, we get 2x plus 7. Remember, x plus 4 squared is x plus 4 times x plus 4. So 2x plus 7 is equal to x squared plus 8x plus 16. We can set it equal to 0. That's how we solve our quadratic. So we subtract 2x and 7 from both sides. And we get x squared plus 6x plus 9. Equals 0. We need 2 numbers that add to 6 and multiply to 3. Sorry. Add to 6 and multiply to 9. Those are both 3s. I'm going to bring this up here. So we get x plus 3 times x plus 3 is equal to 0, or in both cases, x plus 3 equals 0, or x equals negative 3. So we only have one solution here. We need to plug it in to make sure that we get that it's not extraneous. Square root of 2 times negative 3 plus 7 minus negative 3. So be careful about that. Is equal to 4. This is square root of negative 6 plus 7. And this becomes a plus 3. Or square root of 1 plus 3. Or 1 plus 3 equals 4. And that is the case. So x equals negative 3 is a solution. It is not extraneous. Okay, let's do one last one. Try it on your own. 2 times the square root of x minus x equals negative 3. So once again, we want to isolate. So we're going to add x to both sides. That means that we're going to have 2 times the square root of x is equal to x minus 3. Now you can divide by 2 here, but think about it. That is going to make your life more difficult because then you're going to have fractions. It is much easier here, even though we're not completely isolating it, and this is where sometimes you have to think outside the box. When we square this, we can distribute the square, and it actually makes our life much easier. So what we get here when we distribute that square is we get 4 times x. And that prevents us from essentially having to get rid of fractions later and multiply everything by 4 anyway. So we get 4x equals x minus 3 times x minus 3. 4x equals x squared minus 6x plus 9. We set it equal to 0. Subtract 4x from both sides. This gives us x squared minus 10x plus 9 equals 0. Two numbers that add to negative 10 and multiply to 9. That's a negative 9 and a negative 1. So I'm going to bring this up here. X minus 9 times x minus 1 equals 0. X minus 9 equals 0, or x equals 9. X minus 1 equals 0, or x equals 1. We need to check for both of them and make sure that neither one is extraneous. So we have 2 times the square root of 9 minus 9 equals negative 3. So 2 times 3 minus 9 equals negative 3, or 6 minus 9 equals negative 3. This is true. So x equals 9 is a solution. We can box it. Now we're going to do the same thing for the negative 1. For the positive 1. 2 times the square root of 1 minus 1 is equal to negative 3. 2 times 1 minus 1 equals negative 3. 2 minus 1 is not equal to negative 3. This is not a solution. This is extraneous. And we're done. And that's how so isolate your radical. If you can't isolate a single radical, make sure that you have a radical on each side. And if you're multiplying by a constant, then sometimes it can be just as beneficial to square that constant as well and get rid of the constant. Okay, notice equations with radicals, we're only dealing with indexes of 2 in this class. That's all.